to solve this thing, that's the topic of a separate video. So for now, I'm just going to use, let's see, magic. There we go. And magic tells me that the roots are the following: x equal minus 1, x equals 0, x equal 1, and x equal 5. How did we find these? That is going to require some business with factoring and using the rational root theorem, doing some division. That's a separate video. I'll make a little note here to make a separate video on request. All right. Please request it from me if you want to see where the magic happens in example 2. Okay. So, however, once we do this, what we get is on our number line, we get a root here at minus 1, a root at 0, a root at 1, 3, 4, and a root at 5. Okay. And we know that these must be all the roots because this polynomial has degree 4, and we found 4 roots. That's the maximum number of roots that it can have. Okay. So what we've done is we've divided the whole number line into intervals. There's one interval here, one here, one here, one here, and then one off of this side. Don't forget that one. And that's 1, 2, 3, 4, 5 intervals altogether. And for those 5 intervals, on each one, the function, this guy on the left-hand side, is either positive entirely or negative entirely, and we need to determine which one it is, because we're trying to capture the places where it is positive. So here's how we do it. We do it the same way that we did before. We test it. And I highly suggest, for example, putting this function into your calculator. And if you do that, you can simply plug in using the table feature or the trace feature. You can simply plug in and find whether the thing is positive or negative there. So that's a handy shortcut. I'm going to be doing the same thing, so I'm not actually going to plug in entirely. I'll write down some of the steps so that you can see what I'm doing. But let me see. Here's my testing. So I'm going to start by testing the interval down here, and I'm going to do it by picking a point in this interval. I'll pick the smallest feasible point, -2. And what we're going to do is we're going to test x equal -2. And what does that consist of? Well, it consists of plugging in -2 to the 4th minus 5 times -2 cubed minus -2 squared plus 5 times -2. And what is that whole thing equal to? Well, we can do some plugging in, or if we have the graph handy, we can just, if we have it in our calculators, we can just put the number -2 in there and see what we get. So in this case, when we plug in -2, the answer we get is positive 42. That is bigger than 0, and that means that it is positive. The function is positive down here from -infinity up to -1. So that takes care of this interval. Next, we want to look at the interval from -1 to 0. Now, we have to test something in here, and we can't use the endpoints. So that means we got to test something in the middle. That means we're going to have to use a fraction. Here, I'm going to use 1/2, sort of the natural seeming. Oh, but it's not a positive 1/2. It's a negative 1/2 because it's on the left side of 0 there. And so, if we test x equal -1/2 by plugging it in, -1/2 to the 4th minus 5 times -1/2 cubed minus -1/2 squared plus 5 times -1/2. This one is tricky, but it's not so bad with technology. I get -2 point ... It's -2.0625, but that doesn't matter so much. What really matters is that this thing is less than 0. It's negative. So in between -1 and 0, this graph is negative. So far, what we know is that over in this interval, the graph is positive, it's above the x-axis, and in this interval, it's negative, it's below the x-axis here. Okay. Now we're going to look between 0 and 1, and for this one, we are going to test x equal 1/2. I'm going to plug it in, but I'm not going to copy it all down because I'm doing it using technology to plug it in. And when I plug it in, I get 1.68 something, 1.68 dot dot dot. The key is that this is bigger than 0. So that means when x is 1/2, I never put 1/2, let's mark it in there. When x is 1/2, this function comes out to be positive above the x-axis, which means that it's going to be positive all the way along that little interval between 0 and 1. And now, from 1 to 5, let's go ahead and test that one. Let's test x equal 2. And when x is equal to 2, the function is equal to -18. So that one's less than 0. That means it's negative in between here and here. The graph lies under the x-axis. We get negative values out. That was testing 1, 2. And then let's also test the number 6 up above for x equals 6. And we see that for x equals 6, we also get a positive value is equal to 210. And that's positive. Okay. So here's what we have. We found 4 roots, 4 dividing lines, -1, 0, 1, and 5. And those are the places, those are the numbers that when you plug them in to this thing, they're exactly equal to 0. Now, since this only asks for places where it's bigger than 0, we don't want to include any of these numbers, the -1, the 0, the 1, or the 5. They will not be included. However, since we're actually looking for places where it's positive, where it's bigger than 0, we do want to include all the numbers down here, up to, but not including -1. We want to include all the numbers in the middle here, and we want to include all the numbers up here. Those are the ones that corresponded with the plus sign, since we're looking for things that are bigger than 0. So it's just a matter of capturing those intervals. Let's go ahead and do this here. Here is our... bear with me. Here's our answer. We begin by -infinity up to -1, and notice I put a round parenthesis because that number -1 is not included in my answer. The next interval that we want to include, we're going to skip over the interval between -1 and 0, but we're going to include between 0 and 1. So this is union 0, 1. And then we skip over the interval between 1 and 5, but we continue by doing a union from 5 to infinity. And this is our answer. So I just want to recap for you, because it helps to compartmentalize this problem into steps. Rewinding to the beginning, we were presented with this problem. And we first rearranged things so everything was on the same side. Then we got this version. That's the green circled version is the one I want to work with. It's equivalent to the first one. All we did was subtract things over. And looking at this, we're trying to determine when the thing on the left is bigger than 0. So what are the steps? We set that thing on the left equal to 0, and we solve it. All right, here you have to use rational root theorem, dividing polynomials, etc. And you'll come up with 4 different roots. They are these 4. Those 4 roots form like dividers. They take the number line and they divide it up into chunks. And then to intervals. And each of those intervals we test by picking a number in the interval and plugging it into that green function, that left-hand side function, and seeing whether it comes out to be positive. If so, we mark that interval positive, or negative. If so, we mark that interval negative. And we do that And that builds what we call this sign chart. What the sign chart does is it tells us all the places the function is positive, and then 0, and then negative, and then 0, and then positive, and then 0, and then negative, and then 0, and then positive. And if we were to try to draw a sketch of the function, it would look something like this. Positive, negative, positive, negative, positive, like that. Yeah. And just as one final verification before we go, we're going to switch ourselves over to Desmos, and we'll just look there at the graph of this function. It's the function I'm calling g of x. And if you zoom out, you can see it goes sort of down and up quite strongly in the y direction. So if we zoom into it, you can see that indeed it does cross the x-axis at x equal -1, at x equals 0, at x equal 1, and at x equal 5. And in between those places, it's above and below the x-axis in just the ways that we determined. So that's a good confirmation. Great.